algebra students, this is our introduction video for our lesson that's about the number of possible solutions for a system. When we think about graphs of systems of equations, at this point we've talked about you can solve a system of equations by graphing both lines. So maybe your graph looks something like this. And then that solution is where those two lines intersect. So for this one, for example, we would have the solution 2, -2. And there is only one solution because there is only one spot those two lines intersect. Now for a lot of our systems, this is true. Our graph looks something like this. But there are two other possibilities, which is what this lesson is all about. For example, you could have two lines that you graph that maybe look something like this. And then you graph the second line, and it looks like this. If I look at these two lines, we said the solution is that point of intersection. But these two lines I've graphed don't intersect. There is no point that is on the orange line and also the blue line. So if we talk about solutions as the intersection points, here there's no intersection point, and so our answer would be there is no solution. There is no point that would satisfy and be a solution for both equations. There's another option for what could happen. Maybe you graph your first line and it is right here. And then when you graph your second line, it's in the same place. It's got the same y-intercept, the same slope, the same everything. It is the exact same graph. Well, again, we talk about solutions being that point of intersection, that point that's on both of the lines. But here, there's a lot of intersection points because there are a lot of points that would be on both my blue line and my green line. And so here, I can't just say one point because there's so many of them. And the answer to a system like this would be there are infinitely many solutions. Infinite just means there are so many we cannot count. I marked 6 yellow points on this graph, but remember, there's going to be even more than that. And also that these lines go forever in both directions, so there's no way for me to count. There is infinitely many solutions. These are our 3 possibilities when we talk about how many solutions there are. Up until this point, all of the systems I have given you have had one solution. And if a system has one solution, this is your answer. It is the point, that intersection point that lies on both lines and is the solution for both. But no solution and infinitely many solutions are also possibilities. Now we did this with graphs, but if you were solving algebraically, either with substitution or elimination, it would look a little different because you wouldn't have the picture to help you know which one is which. So for example, if I gave you this system here and asked you to solve it, looking at it, we don't realize there's anything different about it. I know I've got y equals 2x, so I would be using substitution. I would replace 2x with my y. And if I do that, I get the equation 2x minus, and then here's my substitution. I take out my y and I replace 2x. And the rest of my equation says equals 10. When I go to solve this, 2x minus 2x, that's 0. That's nothing. That's not x, because if you write x, that means 2 minus 2 is 1, and I don't want to say that. 2x minus 2x is nothing, and so my equation becomes 0 equals 10. This is weird. We're used to our answer saying x is a number and y is a number, but this does not say that. This says 0 equals 10. 0 equals 10 is not true. And so in situations like these where you do not have an x equal to a number and a y equal to a number, the way we decide our answer depends on our results. If I get something that is not true, that helps me know that my answer is going to be no solution. there is no point that I could substitute in here to make 0 equal 10. There is going to be no point that is on both of these lines. Means if I were to graph these lines, they would look something like this. They would look like parallel lines. There's another possibility. If I were to solve this system here, again, the process would be really similar. Y equals 2x, so I could use substitution. I could put 2x here for my y. And when we do that, we get 2x minus, here comes the substitution. I take out y, I replace 2x, and our equation says 2x minus 2x equals 0. When I go to solve this equation, 2x minus 2x is 0, and so I get 0 equals 0. Again, I don't have this. I don't have x equal to a number or y equal to a number, but this time I have something that is true. 0 does equal 0. And so if you're left with a result that is true, this is going to help us know that this system has infinitely many solutions. If I were to graph this system, it would look like this last graph right here, where they have the same graph, the same line. That's because these equations look different, but they're actually equivalent equations. For that second equation, if I move y to the other side, it's just 2x equals y. It's the same equation. And so there is a number of possibilities. There are infinitely many possibilities where they would be a solution to both equations because they're the same. In today's lesson, we're going to be looking at more systems like this that have no solution or infinitely many solutions, and talk about how you can solve systems like these. Thanks so much for watching.